Hi, my name is Michael Mustard, and today I'd like to talk with you about transformations. This is a topic that's covered here in British Columbia in grade 12 pre-calculus math. And the reason I'm telling you about it is because this topic, probably more than any other, is a source for students in grade 12 who come to me looking for math help. And they often have a story when they come to me. In fact, sometimes I'll play a little game with them. They'll come in and I'll say, you don't have to say anything to me. I'll tell you why you're here. And they're like, okay. I'm like, so you're doing transformations? Yes. And you learned the different transformations? Yeah. You did all the homework, or most of the homework, and you got the questions right? Yes. And then you went into the test, you wrote the test, felt pretty good about it, maybe 80, maybe 90, felt reasonably good. And you got the test back and you got 55 or 60. And they're like, how did you know? And I say, but wait, there's more. If you've looked at your test, what you'll notice is there'll be some questions in there, and you'll look at the questions and go, I answered this question or a question just like this in my homework. I know how to do this question, but it's as if an alien took over my brain in the middle of the test, and what's here, I don't even recognize this. What was I thinking? And, at this point, they'll probably accuse me of some sort of mind reading. What I tell them is, this is not a surprise to me because this is a problem a lot of students have with this particular subject. And the reason is, this is something where they teach you how to do it, but they don't explain why it works. And a lot of what you see happening when you're learning how to do transformations is counterintuitive. And so today I'd like to take a moment to explain how you can understand transformations and why they work the way they do. If you're new to this channel, I answer questions on topics of math and science. If you have questions of your own, please feel free to add them in the comments below. So what is a transformation? Well, essentially, when you're dealing with graphs of functions in mathematics, very often we want to do things to those graphs, stretch them, move them, shift them, expand them, contract them, flip them. And we want to do these things because we're trying to do a process called modeling. And usually we want to take those graphs or those mathematical patterns and match them to some data that we have. For example, maybe you're a stock analyst and you're trying to follow some pattern in the stocks, and you have an equation which you think might kind of follow the same kind of pattern, but you need to move it a little bit, shift it up, stretch it a little bit so it actually fits the data. And this is what transformations do. There's a little exercise we're going to go through here, and it's an exercise that I do with my students. And so I want you to do this along with me. And as you're doing it, I want you to try and imagine that you know nothing about transformations. As I mentioned before, this is an area that a lot of students have trouble with. And the reason why this occurs is because they've learned a set of rules they've been taught, a set of steps to do certain transformations. But these steps are very counterintuitive and actually go against what their brain believes makes sense. And on a test under stress, when they're trying to deal with things they've been taught that don't make sense and things their brain thinks make sense, but that may or may not be correct, the synthesis of those two things ends up producing answers on the test that don't necessarily get a lot of marks. So what I want to do is help you to do that synthesis. That is, to be able to understand why these things that may seem counterintuitive actually do make sense. But in order to do this, we have to first investigate what we already know. So I'm going to imagine we have some function we want to graph. And so we're going to draw a graph of y equals f of x. And then let's say what I'm going to do is I'm going to put a little +2 beside that x, and we're going to graph the function. We're going to graph y equals f of x plus 2. And I have 3 questions that I want you to consider. The first question to consider is, do you think that the effect of adding 2 to x here depends on what the function is? What I mean is, let's say the original function I was graphing was the function y equals x squared, a parabola, right? Well, now I'm graphing the function y equals x plus 2 squared. Or let's say originally I was graphing the function y equals x cubed, and now what I'm graphing is x plus 2 cubed. Obviously, x squared and x cubed are going to look different. They're different functions. They have different graphs. That's not what I'm asking. What I'm asking is, do you think the fact that the plus 2 is being squared in one case and cubed in another affects what it does to the graph? Now, if you don't know the answer to this, I think it would be logically to assume, yeah, if you square something or you cube it, it's usually different, right? So I think we would assume that that has a different effect. It turns out, in fact, that it doesn't. Doesn't matter what the function is. If I add 2 to x, it always has the same effect. I think that's counterintuitive. The second question I'd ask is, when we add 2 to x, do you think on the graph that will have an effect just on the horizontal or x direction, just on the y direction, or maybe on both? Now, if you think about it, I think some people might answer the y direction, someone might answer both, but I think we would imagine that it has to affect the y as well as the x because, well, what have we been taught? What you do to one side of an equation, you do to the other. If I change the right side of the equation, if I make x into x plus 2, surely the left side, the y, is going to change as well. And yet, we know this is only a horizontal transformation. So once again, it's a little counterintuitive. The third question I'd like you to consider is, if this action of adding 2 to x has a horizontal effect, should it move to the right or to the left? Well, I know that if x is 4, if I add 2 to it, that would be 6, and that's to the right. So it would make sense to me that it should move to the right. But if you've learned your transformations, you know it actually moves to the left. So we have these three things that are counterintuitive to us, that the transformations seem to have the same effect no matter what the function is, that something we do to x only seems to affect the x, something we do to y only seems to affect the y, and that what we do seems to have the opposite effect that we would expect. If we add 2 to x, it shifts to the left. If we subtract from x, it moves to the right. If we multiply it by 2, it gets half as wide. Why is it always having the opposite effect? Now, whenever you find something in math like this, where what you think makes sense is wrong, well, you're wrong, and I'm wrong. But that doesn't mean we're being illogical. In fact, we're doing the best with the ideas we have. What we need to do is we need to look at the problem in a different way. We need to find a different paradigm, a different point of view, so that when we look at it from that perspective, we can say, oh, of course it's going to do this because blah, 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 blah. And so now I'd like to give you that point of view for transformations by asking you one more question. And that question is, if I were to graph y equals f of x, and then I were to graph y equals f of x plus 2, how does the function change? Many people will say, oh, well, the function moved to the left or the right too. I didn't ask you how the graph changed. I asked you how the function changed. What is the function on the left side here? Well, it's f, right? It's the thing that is doing something to x. What's the function on the right? Well, it's still f. In fact, when we do the transformation, the function never changes. And this is the key to understand how transformations work. Let me be a little more specific. Let's say that, as you know, a function is something which takes an input, gives you an output. Let's say this particular function randomly takes an input of 5 and gives you an output of 11. So f of 5 is 11. Now, on the left side here, I'm going to ask you a really obvious question. What does x need to be in order for the input to be 5? Well, the answer clearly is 5, right? If x is 5, then the input to the function is 5. Great. Now, this is the same function on the right side here. That means if you give it the same input of 5, it will give you the same output of 11 because it's the same function. The question is, what does x need to be here for the input to be 5? Well, x has to be 3, so that 3 plus 2 is 5. And so now what we can see is how x has changed. X decreased by 2. We can summarize this as follows. Whenever you're doing transformations, the function never changes. So whatever you do to the variable, it responds by doing the opposite in order to compensate so that the function never changes. We can look at a little bit of graphing here on Desmos. I can show you really quickly how this applies in practice. Let's just make up some random equation, let's say x squared plus y squared equals 16. Here we have a circle with a radius of 4. And what I'm going to do is I'm going to copy that over here. And then I'll ask you this question. What do you think will happen if I multiply x by 2? Now, according to our rule, whatever you do to the variable, it will compensate by doing the opposite. So if I multiply x by 2, all of the x values have to halve. They have to divide by 2. In other words, it'll have to shrink horizontally. And there you go, you can see it. We've now shrunk halfway to 0. Let's try the same thing in the y direction. What happens if I multiply y by 3? Well, it should become a third of its original height. And there it is. So as you can see, the basic principle that underlies all transformations is whatever you do to the variable, it will respond by changing the graph in the opposite way so that the function remains the same. If you have any comments or questions, please feel free to add them in the comments below, and please check out some of the other videos on my channel.